Good afternoon, ladies and gentlemen. For those who were here at 12 o'clock, I'm sorry, you have to listen again to me. But I'm happy to introduce today some recent developments in the area, in the domain of flax and hemp fiber composites. So this is a presentation on behalf of the Alliance for European Flax, Linen and Hemp. And it will be about flax and hemp fiber composites, the bio-based solutions for the industry. The contents of this presentation will be, after my short introduction, we will show you a number of new flax and hemp fiber preforms, and with this we will prove you that there is a broad availability of these flax and hemp fiber preforms. They are nowadays as available as carbon and glass fiber preforms are. And we will illustrate this with a number of recent applications of flax and hemp fiber composites. While we are doing that, these applications, we will intermingle it with a number of intermezzos on the properties of flax and hemp fiber composites, on their exceptional vibration and damping performance, on their successful application even in wet and moist environments, and we will end up then with some innovative materials with which we can reach sustainable goals. I will not do this alone. This will be done together with two more people, and may I first introduce to you Professor Vincent PLACET. Vincent. He is from the Université of Franche-Comté in Mulhouse, and Vincent is a specialist in natural fibers, more specifically flax and hemp fibers. And then I'm introducing to you Dr. Gilles KOOLEN. Gilles KOOLEN is a postdoc researcher at the University of Leuven in Belgium, where I also belong to. And Gilles is also a technical advisor to the CELC, to the European Alliance for Flax, Linen and Hemp Fibers. So what is the Alliance for European Flax, Linen and Hemp? Well, it's an alliance of all the people, all the companies, all the agricultural people involved in flax and hemp growing, cultivation, fiber extraction, and so on. And their goal is to make European flax, linen, and hemp the preferred sustainable premium fibers worldwide. CELC, the Alliance for European Flax, Linen and Hemp, is the only European agro-industrial organization that serves as a global reference and brings together all the players, as I have mentioned, in the European flax, linen and hemp value chain. And all the players, that's really a lot. These are more than 10,000 companies distributed over 16 European countries. What is CELC doing? We inform members, brands, mainly in the textile industry, the textile industry for clothing and things like that, industrials, which are using flax fibers, for instance, for composite reinforcements, and customers. We support the whole flax and linen and hemp related European ecosystem and know-how, and of course CELC is promoting also European flax, linen and hemp. Western Europe is in fact the world leader in flax fibers. Not only in quantity. It might be surprising to you, but 3/4 of all the flax and linen, or of all the flax which is grown in the world, is grown in 3 countries, Belgium, France, and the Netherlands. It's 145,000 hectares and an annual production in 2022 of 268,000 tons. And there was an increase of 130% in surface area over the last 10 years. We are also the leader in quality. We have the right climate and the right know-how so that flax linen is hard to be relocated. The flax linen cultivation is hard to be relocated elsewhere. And even more, there is a tendency now to re-industrialize, to bring back the spinning mills from other countries back to Belgium. As an example, in France and Portugal, there is an addition of 6 spinning mills, which are, in addition, there is 3 new spinning mills and 6 ones are already running in Europe. We are also world leader in responsibility. We have a very positive life cycle analysis record with flax fibers. We respect people and the planet, of course, and we have proven remarkable properties of the fibers, and we implement certified traceability. And of these proven remarkable properties, that will be the main subject of the further presentation. This is not only our own way, our only way of communicating with the composites community. We have been publishing over the past years several books. As you see, the books Flax and Hemp, Fibre, Composites, A Market Reality, which is available through CLC and through GEC. We have a directory where you can find all the companies involved in flax and hemp fibers for composites. We publish technical reports where we discuss the specific added values of flax and hemp fibers, and we have been proposing technical data sheets which are similar to the ones used in the glass and carbon fiber industry, so that we can present reliable, reproducible data on these fibers. And CLC has been recently developing a life cycle assessment study on European scotched flax fiber, but I will come back to that at the end of the presentation. As I said, we have in Europe here a broad availability of all kinds of flax and hemp fiber preforms. There are a lot of companies who are producing them at this moment. You see them all presented at the bottom of the slide, and you can also visit them all at the Natural Fiber Village, which is close by here, 3 minutes walking in Hall 5 here. So all the preforms which we have available for glass and carbon fibers are nowadays available in flax fibers. And that's something which, when 10 years ago I would be standing here, I could not say that. So there has been really a dramatic evolution in making available flax fibers in all the preforms that we are used in composites industry when we use glass and carbon fibers. So we have short fiber compounds for injection molding, for SMC and BMC. We have unidirectional rovings, where we have rovings, we have unidirectional tapes, we have two-dimensional weaves, we have, these are dry preforms to the left. To the right you see pre-impregnated preforms, prepregs, UD prepregs, woven prepregs. We have non-woven materials, both dry and in prepreg form. We have non-crimp fabrics, uniaxial but also multi-axial non-crimp fabrics. We have hybrid materials where, for instance, carbon and flax are combined, and even we can produce knits if we need special formability properties. I will just, to end up my first part of the presentation, I will just highlight a few new developments. We could give much more, but I will only present 3. This is a preprex flex roving, which has, so it's impregnated with thermoplastic matrix via a dry powder impregnation. It's developed by the company De Pestele here in France. The matrix systems can be either epoxy, so they have also dry impregnated, powder impregnated epoxy prepregs, or it are PA11 or other thermoplastics on demand. I will not highlight all the properties, you can read it yourself. We have very high tensile strength to facilitate. The preform should be strong enough that it can be used in different processes. We have materials which can even be based up to 100% bio-based. And the application of these prepregs can be as well in automated fiber placement, in pultrusion, as in filament winding. Another is by Texinov, the Flaxinov range of materials, which is either on the top you see a warp knitted mesh, which is 100% flax, which is very conformable. In the middle you see the spacer fabric, which is a 3D spacer fabric, which allows you to realize much thicker preforms and is excellent for impact absorption. And Flaxinov, which is a grid material and which can be used for if you need an open work fabric. You can also tailor the yarn spacing, and it's moreover a non-crimp fabric. And finally, there is this nice material variant by the company Culture-In. It's a woven fabric, and it is a combination of a flex yarn together with a composite yarn, which consists of flax and thermoplastic. So it has overall 60% flax and 40% thermoplastic. Thermoplastic can be either PLA or PP or others. And the interesting thing is here that by adapting the temperature and the pressure, you can create very different materials. If you use low temperature and low pressure and intermediate temperature, you have a kind of transparent, semi-flexible preform. If you increase both temperature and pressure, you get really a solid laminate with a smooth surface. So all this proves that what I said in the beginning, indeed these preforms are now widely available, and we have the same preforms as we have in the glass and carbon fiber industry. So now Gilles and Vincent will explain to you some recent applications on one hand and some specific properties of these composites on the other hand. Gilles.
Thank you, Professor VERPOEST. Good afternoon, everybody. My name is Gilles KOOLEN. I'm a postdoc researcher in Leuven, as Ignaas briefly mentioned. And today I have the pleasure to show some recent applications of flax and hemp fiber composites. And while I show some applications, Dr. Vincent PLACET will provide some deeper insights of some of the remarkable properties of these sustainable engineering materials. And yeah, that's how we will tackle this presentation together. So the first example to show is the A110 Eternity concept car by Alpine. Terre de Lin Technic rovings here were used to produce the hood, the roof and interior parts. So these Terre de Lin Technic rovings are produced of untwisted flax yarn, which are wrapped with a cotton or a polyester cover yarn, and is also available in various weights from 200 till 1000 tex. So also one of the interesting developments over the past years is that flax fiber rovings are produced or are used by well-established composite preform manufacturers. And you can actually see the rovings of Terre de Lin and also the rovings of various other members within the Alliance on multiple places throughout the exhibition. So flax fibers, they expand wider than only in the natural fiber village. So in this specific example, flax fibers were used to reduce the weight and decrease the energy consumption of this car. Of course, it also benefits from the good vibration damping performance to enhance comfort. And also designers like this material very much, as it looks very good as well. So the second example is the product Aeroflex by Lufthansa Technik. So it is also very interesting that soon the entire cabin lining can be made of flax fiber composites. And here in this example, B-Comp Amplitex and B-Comp power ribs reinforcements were used. And with an innovative fiber treatment and an innovative resin treatment, B-Comp was able to achieve the fire-resistant requirements in the aerospace. And with using these innovative flax fiber reinforcements like Amplitex and power ribs, they increased the flexural stiffness of the composite parts with a minimal weight increase. So if you compare it with the glass fiber alternative, in this example, a weight saving up to 20% was used. So yes, flax fibers are definitely an engineering material, and they have really good mechanical performance as well. And if you save weight in a transportation or an aerospace application, you of course also save fuel consumption. So now I will give the word to Dr. PLACET, who will explain a bit more.
Thank you, Gilles, and good afternoon, everyone. So in this intermezzo slide, I would like to emphasize the main strengths and advantages of flax and hemp fibers, and as mentioned just before, the weight of these fibers is an important advantage. They are stiff, strong, but they have also a low weight, so with a specific density of approximately 1.5, which is significantly lower than glass fibers. So at the scale of the composite, you can obtain specific bending strengths, as you can see on the graph on the right part of the slide, that outperform aluminum, steel, and glass fiber composites. So it's really one of the key points of these materials. And this weight aspect has also to be considered when doing cost analysis, because most of the time, we use as a unit the mass, the price per mass unit, euro per kilogram, when talking about the fibers. But since when designing composite parts, you can save some mass with flax and hemp fibers, we consider that it's not a fair basis, and we propose to prefer another unit like a cost expressed by a unit of volume, like euro per liter. Indeed, as you can see on this slide, we have a very simple example of the design, the sizing of a plate, a composite plate under bending. And if we design it to obtain a targeted deflection, like it's the case in this example, you can see that we obtain a different thickness for the plate made of flax fibers and glass fibers, but we have also different masses. 2.2 kilograms for the flax composite and 3.5 kilograms for the glass composite. So it makes sense to introduce a new unit, or to use this unit euro per liter to make the comparison.
So we will continue with some other nice examples. So this is from Demji. That is one of our thermoplastic processing experts within the Alliance. And here they introduced their product FlexComp Clear, which is a combination of flex fibers and transparent thermoplastic matrix. So they're using a hybrid process, so both thermocompression as well as overmolding by injection. And with this overmolding process, you can improve or you can add functionalities to your product. So for example, you can make connection points to fit it with other parts or within your full structure, but also, for example, increase the local thickness of the part to, again, increase the local bending stiffness or bending properties. So DEMG can customize this material according to your needs, and it is also suitable for high volume composite production. So another example is the Babolat Pure Aero tennis racket. So this was developed, or Ecotechnilain co-developed this product. And what is interesting is that here flax fibers are placed at specific locations in the racket, and they did this placement, or they decided where to place these inserts based on the user experience. So they really asked the athletes to find out where the best position was. And then in the second phase of testing, they performed extensive mechanical tests. What is also interesting to say is that Ecotechnilain produced flex fiber reinforcements specifically for this application. And here the remarkable properties or the vibration damping performance of flex fibers were used to reduce vibrations at impact, so it's better enhanced feeling when you hit the ball, and also the sound is more muffled and softer, which is also more pleasant on the court.
Yes, damping is another key property of flax and hemp fibers. This excellent damping can be used in composite materials and composite parts. As you can see on the graph, the HB diagram that we have adapted, giving the loss factor as a function of the elastic modulus. You can see that plant fibers, and in particular flax and hemp fibers, have really a higher damping capacity, at least 2 to 3 times higher than the classical composites made of glass and carbon fibers. So with flax and hemp fibers, we can obtain a really good compromise between the stiffness and the damping, and it's something that can be used in the structures to improve vibration damping and acoustic comfort of the vehicles. If you want to learn more about this topic, you can have a look into the technical report published by the Alliance, Vibration Damping in Flax and Hemp Fiber Composites.
To continue with an example in marine conditions. So here is another example where the rovings of Terre-de-Lin were used. This is the We Explore catamaran of Oud-Remer catamarans and Kairos. So this 18-meter deck of flax fiber composites is one of the largest parts of flax fiber composites ever produced. Of course, it is used to reduce the environmental footprint of this product. And actually, a very similar process can be used with flax fibers compared to glass fiber boats. So, the products can be quite easily adaptable. And even if there may be some higher safety factors used for the use of flax fibers in marine environments, still the weight of this product was comparable. So the flax fiber weight was comparable with the glass fiber alternative. This example, and I think also many other marine examples show that flax fibers can really be used in harsh marine environments. But there it is then important to use the right precautionary measures. like, for example, the use of barrier coatings.
Yes, indeed, durability is most of the time seen as a hot issue when talking about plant fiber composite, because it's true that plant fibers are sensitive to moisture, but as it was demonstrated, it does not prevent to use this material for this type of applications in contact with moisture and liquid water if you use the good protections or you use the good design considerations. So all the materials are more or less influenced by environmental factors. For example, metals are sensitive to corrosion, so it's the same for composite. We have to use the good protection depending on the type of climate or conditions to which the material is exposed. And to cope with this moisture sensitivity, we proposed at first to discriminate the type of environment. So indoor climate, outdoor climate, contact with liquid water or immersion. And depending on the use, you can use different solutions. And the general guidelines are at first to control moisture before the composite manufacturing, before the production of the composite parts, to seal the machine heads. And depending on the use conditions, for example, for indoor climate, we have not observed really modification of the properties of the composite. We can see that even if the moisture content increases, when the composite comes back to the equilibrium, we have a reversibility in the mechanical properties. For outdoor climate, we have more severe conditions, and then it's advised to use top coat, as it's done for carbon and glass composites, for example, but also to take into account the reduction in elastic properties and strength in the design and in the sizing of the parts. And for immersion, as it was mentioned in the previous examples, it's advised to take special cautions and additional measures like a barrier coating to limit the moisture diffusion in the material. So as a conclusion, I would say that flax and hemp fiber composites may be sensitive to moisture, but it does not withhold their use in demanding applications.
Very briefly on the last application I wanted to show. This is a racing car from BMW, and B-Comp is, as probably some of you will know, also very active in this segment. And what is also important of this application is that here 85% reduction of the CO2 emissions were achieved when using this flax fiber solution instead of the carbon fiber solution.
And the last key aspect that we would like to emphasize regarding the flax and hemp properties is the environmental footprint. You need less energy to produce flax and hemp fibers when compared to glass and carbon fibers. You can see the figures on the slide. And with hackled flax fibers, for example, we have a reduced impact on all impact categories that you generally consider when doing a life cycle assessment, except, of course, for the land use and eutrophication, which are directly linked to the growth of the fibers. So I think it's now time to wrap up the presentation, and I give back to the microphone to Ignaas.
So thank you very much, Gilles and Vincent, for your excellent presentation. I want to finish by saying that the CLC is now in the process of publishing their results of the LCA analysis of scotched fibers. This is very important. This is done in accordance with the new regulations of the European Commission the PEF system, which they have installed, the product environmental footprint methodology. These data are now available for scotched fibers and will be later on expanded to heckled, carded fibers and to further spun fibers. So by 2024, all these data will be available in the European databases, and with this, the flex fibers sorry, will be one of the first of all the fibers in composites where we have those reliable data available. So we are a little bit over time, my excuses for this, so we have no time for questions, but you can reach all the people, you can reach Gilles and Vincent, you can also talk to Julie, who is sitting there, please stand up, Julie, who is the CLC responsible, who can also answer all your questions in the Natural Fiber Village, which is just across the place here. So thank you very much for your kind attention.